Construct a truth table for a statement with a disjunction and or a negation. Well, what do these words mean? Well, a disjunction is an or statement. So talking about P or Q. When you're talking about a disjunction, an or statement, only one statement needs to be true for the entire disjunction to be true. If both P and Q are false, then the entire disjunction is false. Now, a negation simply means the opposite truth value. So if you're given statement P, then the negation of that is not P. So we use this squiggly to show negation. Let's construct a truth table that shows P and not Q, and not P or Q. And are these two things logically equivalent? Now, logically equivalent means the line in the truth table, as they go down, exactly the same. Okay, so let's think about our truth table. I have P and Q, so I have two statements, so I would take 2 squared. I need 4 lines. So when I'm thinking P and Q, my first one, if it's 4 lines, that means half are true and half are false. The next one, I would say, okay, so for the 2 truths, I need a true and a false. For the 2 falses, I need a true and a false. Okay, so let's look, oh, wrong button. So let's look at our next one. I need to show P or not Q. Well, first let's do not Q. So remember when we're dealing with negations, it's the opposite truth value. So I'm going to look at my Q line here, my Q column, and I'm going to negate it. So when I see a true in the Q, that becomes a false in the not Q. If it's false with Q, it's true in not Q, right? It's just the opposite. Now I can do P or not Q. So I am looking at the P column and the not Q column. I'm comparing those two, and we're using or, right? The disjunction or, meaning only one of them must be true. Okay, so I have true, false. Well, that's true. True, true. That's true. False, false. Ooh, that's false. And then false, true. That's true. Okay, so that's the first one I want to look at. Now I'm playing with not P or Q. So again, I have a negation. So let's negate not P. So I look at my P column and say, let's just change the truth values. So instead of true, true, false, false, I have false, false, true, true. And now I can use not P or Q. So I'm comparing my not P column that I just created and Q. Those are the 2 columns I'm looking at. And again, it's an or, right? It's a disjunction. So only one of these has to be true. Okay, so true, false. That's true. False, false. Ooh, that's false. True, true. True, false, true. True. So the last part of this is, are these 2 logically equivalent? So if you compare this and this, are they the same? We have true, 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 false. No, these are not logically equivalent. Let's look at the next one. Create a truth table to find the truth value of the following. Not P or Q. If P is 3 plus 2 is less than 7 and Q is 6 times 3 is less than 10. Well, let's think about P and Q here for a second. 3 plus 2 is 5. Is 5 less than 7? Yes. So P is true because 5 is less than 7. Let's look at Q. 6 times 3 is 18. Is 18 less than 10? No. Q is false. So if we're thinking about our truth table, okay, we've got P and Q. But what do we know? We know that P is true and we know Q is false. Okay? So we're trying to find not P or Q. So first I start with not P. Well, P is true. That means not P is false. So now if I want not P or Q, I'm looking at not P, I'm looking at Q, and or, the disjunction means just one of these must be true. Well, false, false, not P or Q is false. So you'll notice I did not create a full truth table. I just used the part of the truth table that was needed for the information I was given. Now, let's consider the truth table I created earlier, and let's extend it to be to give us P or not Q, or not P. Now, I know we did one earlier, but I want to kind of talk through this a little bit. Now, first things first, I've got the P and the Q, and then anytime you notice that you have negations, get yourself your negation pieces, right? So not P is literally just the opposite of P. So instead of true, true, false, false, I'm false, false, true, true. Not Q is the opposite of Q. So if Q is true, false, then not Q is false, true. When we're looking at a statement such as this, it's got some different pieces to it. So we first need to do the piece that's in parentheses. It's kind of like the order of operations in mathematics. So first I'm going to find P or not Q. So I'm looking at my P column, my not Q column. And because this is a disjunction of or, I'm just looking for one of them to be true. True, false, true, true, false, 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 true. Now that I have that piece, now I can say, okay, if I have P or not Q, or not P. So now I'm looking at this column, right? That's the left side. Not P is the other side. And it's a disjunction of or, which means only one of those has to be true. So true, false, false, true, true, true. So P or not Q or not P is always true. Isn't that exciting? Maybe, maybe not, I don't know.